The sixth problem of ours is another very important problem. Such kind of problems has also appeared in JEE a few years back. We want to find the number of proper divisors of the number which is represented in the form of 2 power p into 3 power q into 5 power r, and also we need to find the sum of all the divisors of this number, the proper divisors of this number, and all proper divisors of this number which are of the form 3k, that is, they are multiples of 3. So let us start with finding out the number of proper divisors of this number. Now the total number of proper divisors are equal to the total number of divisors of the number minus the divisor 1 minus the divisor the number itself. Hence we should find out the total number of divisors and subtract 2 from it, because there are 2 divisors, 1 and the number itself. The total number of divisors can be very easily found out. The number is represented by 2 power p into 3 power q into 5 power r. This 2 can be selected in p plus 1 ways, that is selecting 1p, 2p, 3p up till 5p's, and the p plus 1th case is selecting no 2. So there are p plus 1 ways of selecting 2. Similarly, there are q plus 1 ways of selecting 3, and there are r plus 1 ways of selecting 5. Hence the total number of ways of making a divisor for this number is p plus 1 into q plus 1 into r plus 1, but we have to subtract this 2 in order to find the total number of proper divisors. This 2 represents the number 1 and the number itself. When we subtract these 2 divisors from all other divisors, then we get the total number of proper divisors. Hence the total number of proper divisors of n are p plus 1 into q plus 1 into r plus 1 minus 2. And this is our answer for this part. We can write the answer over here: p plus 1 into q plus 1 into r plus 1 minus 2. So now let us find the sum of all divisors. This number is 2 power p into 3 power q into 5 power r, and we know that p can range from 0 to p, q can range from 0 to q, and r can range from 0 to r, because we can select 0 p's, 1 p's, 2 p's up till p p's. Similarly 0 to q over here and 0 to r over here. So sum is equal to sigma n, which is equal to sigma 2 power p, 3 power q, 5 power r. This is equal to sigma 2 power p, p equals 0 to p, sigma 3 power q, q is equal to 0 to q, and r is equal to 0 to r sigma 5 power r. This is very important thing, because most of the students do the summation from p is equal to 1 to p, but this is very important case when no p, no q and no r is selected. So p ranges from 0 to p and not from 1 to p. This is a GP having the first term 1 and the last term 2 power p. So total number of terms are p plus 1. Hence the sum is 2 power p plus 1 minus 1 upon 2 minus 1 into 3 power q plus 1 minus 1 upon 3 minus 1 into 5 power r plus 1 minus 1 upon 5 minus 1, and this is our answer for the sum of all divisors. Now in order to find the sum of proper divisors, we know that the 2 improper divisors are 1 and the number itself. So if we subtract 1 plus 2 power p, 3 power q, 5 power r, which is the number itself, from this sum we will get the sum of all proper divisors. If this is represented by s, then the answer for B part is s minus. If this is represented by, let's say, s dash, the answer is s minus s dash, which is the sum of all the divisors minus sum of the 2 improper divisors, which are 1 and the number itself. Now let us try to find out the sum of all proper divisors of the number which are of the form 3k. So let us convert this number in the form of 3 into k. This n can be written as 3 into 2 power p, 3 power q minus 1, 5 power r. This is equal to 3n dash. So sigma n is equal to 3 times sigma n dash, which is equal to 3 times summation p is equal to 0 till p 2 power p, as we did earlier. Summation r is equal to 0 till r 5 power r, as we did earlier. But now q belongs to from 1 to q and not from 0 to q, because one of the q's has been taken outside the summation in order to convert the factor in 3 sigma n dash form. So this becomes q is equal to 1 to q and not from 0 to q, 3 power q. Now there are p plus 1 terms over here, so the summation is 2 power q p plus 1 minus 1 upon 2 minus 1 into 5 power r plus 1 minus 1 upon 5 minus 1 into 3 power q minus 1 upon 3 minus 1. Here there is q and not q plus 1. So this is the sum of all the proper divisors of the number of the form 3k, and hence our final answers are, number of proper divisors are p plus 1 into q plus 1 into r plus 1 minus 2. Sum of all divisors is this. Sum of the proper divisors is the sum this minus the two improper divisors, which are 1 and the number itself. And the answer for the fourth part, that is the sum of all proper divisors of the form 3k, is this. And these are our final answers.